Tuning an image signal processor, or ISP, for embedded video systems, such as automotive ADAS, autonomous robots, surveillance cameras, medical devices, or drones, is a multi-stage process. It requires balancing image quality, reliability, and computer vision performance. At Xylon, we specialize in implementing and tuning ISP pipelines to AMD FPGAs and adaptive SoCs, but the overall process follows a set of key phases. Everything starts with understanding the system. We work closely with the customer to define where the camera will be used and under what conditions it needs to perform. For example, tuning a camera for orbiting Earth is very different from tuning a camera for an automotive system that must handle tunnels, night driving, and direct sunlight. There is also a difference between tuning for human perception and tuning for machine vision algorithms. Each use case has its own problems, and that shapes the entire ISP pipeline. Next, we move into the lab. Here we perform a detailed sensor characterization to understand the raw signal before any processing is applied. We measure things like sensor noise, dynamic range, and light response. This step is essential for building a solid foundation. It also often involves close collaboration with sensor manufacturer to obtain detailed technical data. We use specialized lab equipment, along with both third-party and in-house image analysis tools. A well-tuned ISP must perform across a wide range of real-world conditions. That's why we rely on real-world video data captured in these specific scenarios. Sometimes the customer provides the data and sometimes we capture it ourselves. For example, through test drives. Our Logic Recorder automotive video data logger is especially useful here, as it allows us to record realistic driving scenes that can later be reproduced in the lab for tuning and analysis. To achieve optimal image quality, we fine-tune different stages of the ISP pipeline. This includes auto-white balance, auto-exposure, and especially HDR performance. At Xylon, we've developed a flexible Logi ISP HDR pipeline for AMD programmable devices. Unlike fixed architectures, this approach allows tuning at both the software and hardware level. We use our ISP Studio PC application to compare multiple pipeline configurations in parallel. With real camera input and bit-accurate simulations, we can evaluate both visual results and analytical metrics at each stage of the pipeline. This enables fast iteration. What used to take hours can now be done in minutes. Finally, the tuned ISP must be validated on real hardware. Since we focus on embedded systems based on AMD FPGAs and SoCs, we use development platforms or custom customer hardware to confirm correct operation. Working hardware allows us to retest in real-world conditions, capture additional video, and verify key performance indicators. This ensures that the tuned ISP performs reliably outside of the lab environment. As you can see, tuning an ISP pipeline is not a trivial task, but with the right tools and an experienced team, it becomes significantly more efficient and predictable. Xylon's dedicated ISP team has successfully delivered dozens of projects across different embedded markets, from space applications in orbit to borescope system used to inspect hard-to-reach areas.